Hello, everyone, and welcome. Thank you so much for joining me here at TriSwift Tokyo 2025. I'm very happy to be here today to explore a topic I found very interesting, how Swift and generative AI unlock a new era of spatial computing. Before we start, let me quickly introduce myself. My name is Ryo Igarashi, and call me Igario. I love technology and engineering. Right now, I'm very interested in autonomous driving. Actually, last week, I visited Los Angeles, and I tried Waymo Robotaxi for the first time. It was so amazing to see this future technology. I'm working as a software engineer on the autonomous driving team at Numo. Last year, we published a taxi and ride-sharing app, and we've also started developing robotaxis. So, connecting my interest in spatial computing, I want to show you a project that connects the main idea of today's talk. Let's talk about the Model Maker app. Model Maker app is an app made for visionOS that I developed by myself and released on the App Store last year. This is demo video. What you will see is user typing a description like a cute robot or a wooden chair or green apple. After typing the text, you have to wait for a short time while the AI is thinking about the request. And then it takes some minutes. A 3D model that matches the text appears right there, and ready to be looked at and maybe interacted with. Okay, let me tell our plan for this session. We started by covering the basics for visionOS, and then we'll look at the very interesting world of making 3D models using generative AI. After that, I'll show you how the Model Maker app works behind the scene, explaining its system part. Finally, we will think about the future. All right, to really understanding how Model Maker works, we first need to know the main technologies it uses. We'll start by looking at the basics of visionOS and, importantly, how we work with 3D models in new special way. Now, I know many talks today are about visionOS, so most of people probably know about it, but just to be sure, I will give a quick summary. visionOS is Apple's spatial computing platform, the operating system made just for the VisionPro. It shares the basic part with iOS and iPadOS, but visionOS is specially made better for spatial experience, mixing digital things with your real world. visionOS lets us do what Apple calls spatial computing. Before Apple used this word, we often call similar things AR, augmented reality, or VR, virtual reality. Spatial computing is maybe a bigger idea that connects things. It focuses on mixing digital information and experience smoothly with our physical world, using a natural way to interact, mostly using our eyes or hands, instead of just old controller or keyboard. In visionOS, apps and content smoothly show up in three main ways. First, window. That is like the normal 2D app windows we know from Mac OS or iPad OS. Second, volume. That is separate 3D boxes that float in your space. Third, immersive space. The experience can fill everything you can see and either mixing a little with reality or fully replace it. So, how do we actually put 3D objects into these experiences using Swift? Swift UI gives a very simple way to start with Model 3D view. As you see in this code, it's often as easy as creating Model 3D with the name of the 3D model file in your project, like robot.usdz. Swift UI loads it in the background. This simple way works well inside windows, volumes, or even in an immersive space. And the result of that simple code is what you can see. Our 3D robot model is loaded and shown in the app space. Also, if USDZ file has animations, Model 3D will often load and play those automatically too, making your models come alive easily. Whilst Model 3D is great for quick and easy showing, the real main tool for advanced 3D graphics on Apple's platform is Reality Kit. Reality Kit is Apple's very fast 3D graphics tool. It has a physically based rendering system that is called PBR system to make things look very real. And it's built using an entity component system, ECS idea. When you need more control than Model 3D, use Reality View. It lets you load specific models, add them to the scene, and precisely set their position, size, or look. Understanding Reality Kit basic parts helps you use Reality View effectively. Reality Kit uses ECS. Key parts are entity, component, anchor entity, and scene model entity. This ECS approach helps keep your 3D scene organized and enable make complex 3D scene. To make 3D models look real, Reality Kit uses PBR. PBR copies how light hits real surfaces. Instead of just a single color, you use PBR settings like base color, roughness, and metallic. Changing these settings let you create many realistic looks, like plastic or metal. In these examples, you often saw the .usdz file name. So what is USDZ? It means Universal Scene Description ZIP. The basic idea USD was first made by Pixar Animation Studio for the movie-making process. Apple worked with Pixar to make USDZ, a special ZIP file made just for sharing and using USDZ scene. It puts together the 3D model shape, colors, animations, physics, and maybe other things into one easy file. The reason why Apple suggests USDZ for AR and 3D things on its platform is easy to see what you look at its feature. Easy sharing as one file makes sharing and loading very easy. PBR materials for a very real look. Animation, including different kinds of animation. Physics, like how things bump and how heavy they are. Adding sounds, putting sound in 3D scene. Also, USDZ has a built-in AR view on iOS and iPadOS, letting people see models in AR in Safari or Messages without a special app. The code again shows it's easy to load a USDZ file with Reality Kit. OK, USDZ is great and easy. But how do we make these files? They usually come from people using professional 3D programs. Apple gives Reality Composer Pro, parts of Xcode, just for making Reality Kit scenes. And you can save into USDZ from common modeling tools like Blender. But using these tools needs a lot of skill. Making good, fast 3D models is a special skill, takes a lot of time, costs a lot. How can we make creating 3D content easier and faster? This is where AI helps, giving good tools to help us to be creative. Let's look at how we can use AI to make these 3D models. You have probably heard the name generative AI often lately. Basically, it's an interesting part of artificial intelligence. that focuses not just on looking at old data, but on making new things based on ideas from a lot of data. It learns the basic way things are made, like text, images, music, or code, and you can make new things. You might already use it for help with coding, writing emails, or maybe without knowing it in different apps. It can help people to be more creative and make content automatically. Today, we are focusing on its use for making 3D models. When we talk about AI makes 3D models, there are some different ways. Making 3D models from photos using methods like NARF to revert 3D objects from many photos. Modeling tools with AI help, where AI help inside normal 3D modeling tool. But in this session, we will talk about text to 3D model using generative AI. This way, lets people make full 3D models just by writing about them, making it very easy to use, even if you don't know 3D modeling. So, how does a text to 3D model changes your words into a 3D object? How it works inside is very complex, but we can think about the step. As shown here, first, the input text is led by an AI to know what it means, often changing it into a special vector called embedding. Embedding then tells the AI how to make the model, maybe starting with a simple shape. This makes the first 3D model, but this first one may not look good. So then it is made better, step by step, improves the shape, details, and adding colors. Then the finished 3D model comes out. The world of text to 3D model is changing very fast. Important tools have been made. Dream Fusion from Google Research, Shapey from OpenAI, StableFast 3D from Stability AI. There are only some examples of public models. Also, there are many other private models, web services, and always trying to improve how good, fast, and easy to creating text to 3D. Now we know the basics of visionOS 3D graphics, USDZ, and the idea of text to 3D AI. Let's talk about the app that tries to connect these ideas, Model Maker app. Model Maker app is an app made for visionOS, made to make 3D model creation easy to use, using text to tell it what to do. You type what you want, and the app makes it for you. But I have to apologize you because I should mention the app is not working now, mostly because of the cost of the AI server. But I am planning to make it better in a month. Let's look at how Model Maker apps works. The visionOS app talks to main server. This server manages requests and talks to powerful AI server that actually creates the 3D model using AI. The finished model file is saved to cloud storage at Google Cloud, and the main server tells the app where to find it. Here is the basic flow. You type text in app. The app asks the main server to start the job on the AI server. Since making the model takes time, the app needs to check back with the main server. When the AI server is done, the main server saves the create model to storage and connect to database. Then the app can download and show the 3D model. This is simplified client code. To handle this waiting, the app polls the server. It repeatedly checks the job status in the background task, waiting a little bit between checks. When the server says the model is ready, the app updates the screen. If it's not ready, it just waits and tries again later. This is a straightforward way to handle long background process using generative AI. We faced two main challenges building this. First, changing file types. The AI didn't output .usdz directory, so we needed to add a step to convert the file correctly, which requires deep understanding of file format. Second, handling background tasks. The generative AI takes some minutes. So we needed clear loading message for the user and good way to handle errors if something went wrong during the wait. Making this took us a lot, and it shows how things are now. But things are changing very fast. Let's think about the future. Spatial computing has potential in many areas. For example, design in industry, create new type of games, or offer students new way to learn with interactive 3D models. It provides easier way to interact with digital things. Text to 3D model AI is also improving very fast, becoming stronger and simpler. Soon, we might edit 3D models just by talking to AI, use drawing or voice combined with text as input, or even have multiple users create 3D content together using these tools in shared space like spatial computing. The development of Swift and visionOS will also likely get better too. We expect closer connection between Swift and AI, making it easier to learn AI on the device itself using things like Core ML. We also expect better 3D interactions like more realistic physics, and these special AI experiences appearing on more devices, including iPhone or iPad, as ARKit and RealityKit improve. So, to sum up, we talked about visionOS and Swift provide the foundation for spatial computing. Text to 3D technology unlock creative possibilities. Model Maker app serves a bridge between these technologies. Thank you very much for your time and attention. I can answer questions at office hour in both Japanese and English. You can also find me online at Igario. Please follow me. Thank you.